The water cycle. It brings life all over the world, whether it's precipitation, saved in our oceans, or frozen in glaciers high on mountain peaks or at the North and South Poles. Talking about the role of water in cycles of matter. So our next section is going to be talking all about cycles in the ecosystem from water, phosphorus, nitrogen, sulfur. And we're going to be talking about how those nutrients and minerals stay in that ecosystem. So if we think back to earlier in chat unit A, this is referring to how the Earth is a closed system and all that matter cycles. It doesn't ever exit or leave. So because the Earth is a closed system, matter must cycle within it. So except, like I said, for the odd time when an asteroid might come to Earth and bring other nutrients, minerals, and possibly ice, all those components of life on Earth are here on Earth. They're going to stay, and nothing more is going to be coming. The water that we see from surface water sources might have come originally from snow or ice. Here in Alberta, lots of our river water and runoff comes from glaciers. But originally that ice was deposited from snow and rain that had evaporated from the oceans. It may have been the product of cellular respiration. So it all cycles within our ecosystem. So water in our atmosphere acts as a greenhouse gas. Now, you've talked about greenhouse gases in science since you were in elementary school, and water is an important one. If we didn't have water in our atmosphere, it wouldn't trap heat, it wouldn't keep the Earth warm, it would be way too cold for life to exist. The transfer of heat throughout our biosphere is also mainly due to water's ability to absorb large amounts of heat energy. So we're moving heat from over the oceans to over the continents. We're moving heat through hurricanes or absorbing all that water, depositing it somewhere else. And this uses large amounts of heat energy, which is why we see things like hurricanes in tropical regions. So here's an example of the hydrological cycle. And again, you've seen diagrams of this ever since you were in elementary school, where we have precipitation coming from clouds, either going onto the land or going onto water bodies. We have surface runoff that eventually will make its way to the ocean, where we can see evaporation. We have evaporation from trees, evaporation from water, evaporation from soil, where then we'll have condensation and cloud formation, again, leading to precipitation. Now here we have percolation of water down into the soil, where it will become groundwater, where sometimes that water can be trapped for centuries and decades and eons, where it hasn't made its way to the ocean. And unless we've tapped it for a well to bring up to the surface, it typically will stay as that very deep groundwater in aquifers. The water is also known as a universal solvent. So it's a polar molecule, which means when an ionic compound such as salt is placed in water, it will pull the ions apart to make it dissolve. So the oxygen end is slightly negative, where the two hydrogen ends are slightly positive, using a covalent bond. That's something, again, you learned about in Science 10. And that allows water to be able to dissolve many different components. So as well, there's an attraction formed between water molecules to other water molecules using hydrogen bonds. So this allows the water molecules to surround compounds while dissolving them. So salt, for example, would effectively get mixed within the water. This also allows water molecules to behave differently than other components, giving you that surface tension as well as the ability to climb up thin tubes like we would see in plants, so that water can get to the leaves from the ground. And it requires a large amount of energy to break these hydrogen bonds so that the molecules can move freely. So moving from a solid to a liquid or from liquid to a gas phase. So water has very high heats of fusion and vaporization. So water needs to absorb a lot of energy before it can change state. So water, incidentally, has a very high melting point at 0 degrees Celsius and a very high boiling point at 100 degrees Celsius when compared to other similar hydrogen compounds. So like I said, the the hydrogen bonds and the forces of repulsion, so those positive and negatives between the hydrogen atoms, contributes to the open spacing seen in the crystal structure of ice. So we know that ice floats on water because it's less dense. As those water molecules use their hydrogen bonds and fuels together in a solid state, they move apart, leaving more room between them, allowing for ice to be less dense than water. So because ice is less dense than water, lakes always freeze from the top down. So we very rarely there'll be ice at the bottom of a lake. If there's ice at the bottom of a lake or slough, basically nothing can live in it all year. So because ice is less dense than water, we have a thin layer of surface at the top, and it allows, as the water changes temperature, a cycling of the water, which allows for oxygen and nutrients to be moved from the top of the surface of the water to the bottom, and then again from the top to the bottom, again in the spring and the fall turnovers, which allow fish and other organisms to live in lakes year round in the part of the water column that suits them best. So the hydrogen bonds in water produce cohesion between the molecules, like I said, gives it surface tension. Adhesion also occurs between water molecules and molecules such as glass or a straw, giving you that um, meniscus shape that you see. And this also is responsible for the capillary action that occurs in the xylem of plants. So it allows for that water to climb the xylem of plants, getting its way all the way up to the leaves where photosynthesis can occur. So the hydrogen bonds between water molecules means that water has a high specific heat capacity. So it absorbs lots and lots and lots of heat energy before it changes state. So large bodies of water, such as oceans and Great Lakes, typically moderate temperature around them. So if you live in Vancouver or Victoria, you typically have much more mild summers compared to Alberta, where you will have average highs of 18 to 22 degrees. As opposed to here, where we'll have dry, hot days and then really cold, rainy days. But in the winter, we in Alberta will get down to -20, -30 regularly. And in Vancouver and Victoria, because they live right next to that large body of water, they rarely see temperatures below zero because that heat that is being absorbed by the Pacific Ocean constantly gets released to the atmosphere, maintaining a moderate temperature in that area. At the level of the individual organism, the high specific heat capacity prevents body temperatures from changing too quickly. So even though we're out in the sun for a long time, because our body has 70 some percent water, it's more easy for us to maintain that regular body temperature as opposed to if we were a dry substance and we would change temperature. We're in the sun, oh my goodness, we're really hot. We're in the shade, oh my goodness, we're really cold. But organisms typically need to gain water from their environment through eating. So things like fruits, watermelon, um, vegetables typically have a lot of water in them. Drinking anything liquid, absorbing it through our skin, which we don't do super effectively, and through cellular respiration. Organisms typically lose water through breathing, sweating, and in their waste. So, water is a resource that's necessary for many ecosystems. When ecosystems lack water, the producers that use it during photosynthesis quickly disappear. So, if we're looking at a process of desertification in the prairies, if we're getting a lack of rain, a lack of surface water, we slowly start to see the loss of those native prairie grasses, those trees, because they're not used to those drier conditions. Therefore, in areas of drought and in times of drought, they can be really devastating to ecosystems. After the heat wave that came through in 2021, lots of farmers ended up losing their crops in the short term because there's so much water evaporated during the heat wave that a drought occurred in the short term afterwards. In general, if global temperatures rise, then droughts typically are going to become much more common in areas such as Alberta because we don't have a lot of surface water, such as lakes, oceans, rivers, compared to other parts of the world where that water is going to evaporate from. So as the temperatures rise, water is going to be evaporating from our soil and from our trees, leading to a lack of water in the ecosystem. When we look at water quality, not all fresh water is suitable for use. So we have surface water, which is suitable for animals and irrigation and recreation. But in Alberta specifically, surface fresh water is not suitable for drinking. To drink that surface water from lakes or rivers, first we have to take it into a water treatment plant. It's often contaminated with toxic chemicals from runoff in the oil, agricultural industries, as well as urban locations. as well as pathogens that could be contained in human and or animal waste. Even if the pathogens can be killed by chemical treatment or boiling, some toxins are extremely difficult to remove from polluted water, which is why it's recommended only to drink water from treated water sources. Changes in the amount of water available in an ecosystem will affect the growth of producers. So, if we have a lot of rain and a lot of sun, we're going to see an increase in the amount of producers in our area. If we have a decrease in the amount of water, typically we'll see a decrease or even a change of species in the types of producers that we see. In the rainforest, research showed that trees exposed to drought conditions typically extend their roots deeper than they normally would in search of water. And if you see the roots from prairie grasses, they typically will go 6 feet or more into the ground, which is how they can survive drought conditions, as opposed to lawn or crop roots, which extend inches to maybe 1 centimeters to maybe 30 centimeters under the ground looking for water, which is why native plants often are much more adept to surviving drought conditions than introduced and crop species. As well, if we look at the growth of trees decreased, and some of the larger trees died if there was a lack of water in the rainforest. This is because they have a larger demand for water, they have larger leaves, and they need more water than some of the smaller trees. When we look at prairie ecosystems versus wetter ecosystems, like in the West Coast rainforests, we can see this where our largest trees do not get as large as the trees on the coast of Vancouver Island because of the availability of water. This could also contribute to climate change because as larger trees die and their growth slows down, less carbon dioxide is removed from the atmosphere. So trees are considered a carbon sink because they'll pull that carbon dioxide from the atmosphere and store it in the body of the tree. And those large trees that live for hundreds of years contain a lot of carbon dioxide. When we look at the lack of growth in trees and other producers due to drought, it also will affect other chemical cycles in our biosphere because trees act as a resource and a reservoir for other types of nutrient cycles that exist in our biosphere and in our environment. Well, it was great to see you all again today. And tomorrow, or our next lesson, we will be discussing biogeochemical cycles. So we'll be looking at the cycles of other nutrients in the biosphere.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.